So usually when you talk about the cosine and sine functions, you're given the graph and you see that it's a wave, but we don't really talk about why it's wavy. So now that we know all the points along the unit circle, we know all the angles in terms of their radian measure, now we can finally look at the cosine and sine functions and talk about why their graphs look like the way they do. So get your pencil, get your paper, and let's get into it. What's good, YouTube? It's Almond with the Sauce, and I'm back with another video. In this video, we're going to be talking about the cosine and sine functions and what their graphs look like. This video is the fourth and final video of my series where we're trying to figure out what the sine and the cosine graph look like, and we're going to talk about why it looks the way it does. All right, just looking at this circle, if it looks like too much, make sure y'all go watch part 2 and part 3, where we talk about how to come up with all of these points on the circle and talk about all these angles in the circle. So having saw those, now we can talk about the cosine and sine functions. Now, as we've said before, you know that the cosine and sine functions are functions. So they behave just like any other function does. It has an input, which is our angle theta. The output for cosine is going to be the adjacent side over the hypotenuse. And then the output for a sine function was just the opposite side over the hypotenuse. Now, since we're talking about these functions, how they relate to the unit circle, our hypotenuse, if you remember, was the radius, which is 1. So with the cosine and sine of anything in the unit circle, if we're dividing by the hypotenuse, we're dividing by 1, which doesn't do anything. So because we're dividing by 1, the cosine of any theta is just going to be equal to the adjacent side of that triangle. Same thing with the sine function. When we do the opposite divided by 1, that's just going to give us the opposite side of whatever angle our theta is. All right, so talking about these functions and how they relate to the unit circle, if our theta is anywhere from 0 to 2 pi radians, if we're looking at the cosine of that theta, that's just equal to the adjacent side, which, if y'all remember, the adjacent side is the side that's next to theta. And it just so happens that that distance is however long I went to get to the x coordinate on the unit circle. So for example, with pi over 6, remember it makes that 30, 60, 90 triangle. And so the distance from the origin to the x coordinate, which is 3 pi over 2, is that length. And so in that case, if theta was pi over 6, then my adjacent side would be square root of 3 over 2. And as you can see, whatever that adjacent side is, that's equal to the cosine of that angle theta. And then for the sine function, that's equal to the opposite, which, if you remember, is the side across from theta. So this side right here would be the opposite. And if you notice, this vertical distance is however many we went up to get the y coordinate of that point. So this distance right here, our opposite, is also equal to the sine of that theta. So if you can understand where to get all 16 points from the unit circle from, you know the cosine and the sine of that angle. So for example, if I want to take the cosine of 5 pi over 4, for example, I know that that's equal to the x coordinate of whatever point comes from that angle of 5 pi over 4. So if I look at my unit circle, 5 pi over 4 is right here, and the x coordinate is going to be a negative square root of 2 over 2. That is the ratio of the adjacent side to the hypotenuse. Because remember, adjacent just means this horizontal distance right here divided by our hypotenuse of 1. So that's why the cosine of any angle is just the x coordinate of that point. So now if I wanted to take, let's say, the sine of 3 pi over 2, that's just going to give me the y coordinate of whatever point I get at 3 pi over 2 radians, which is 270 degrees, and my y coordinate is going to be -1. And so that's kind of how you can know the cosine and sine functions of all of these theta values, theta being from 0 all the way to 2 pi radians. Since we have all these inputs, let's figure out how to graph the cosine and sine functions. All right, so since we know that cosine and sine are both functions, we can go ahead and graph them. Thinking about what goes on the x and what goes on the y, if you know that that ratio of sides, either that adjacent over hypotenuse or the opposite over hypotenuse, that ratio of sides is going to depend on theta. So theta is your independent variable. So I have from 0 to 2 pi radians on the x-axis. And then on the y-axis, I have all of the outputs, or the opposite over hypotenuse or adjacent over hypotenuse. I'm going to start by graphing the cosine function. And the way we can do that is, again, because cosine is adjacent over 1, all of the adjacent sides are just going to be the x coordinates of all of these points on our unit circle. So at 0 radians, my x coordinate is 1. So I'm going to just plot that point. And then at pi over 6 radians, my x coordinate is square root of 3 over 2. So I'm going to just plot that point. And then I'm gonna just keep doing this as I get from 0 all the way to 2 pi. You'll see what one full cycle of that cosine wave looks like. All right, so I'm just gonna keep graphing these pi over 4, square root of 2 over 2. All right, so now right here, if you look and see, you can just tell that the cosine function is literally just what the x value is, or what the adjacent side is, as theta goes all the way around the circle. So as theta gets bigger and bigger, you can see my x coordinates get smaller and smaller until I get right here, my x coordinate is 0. And then as theta gets bigger and bigger, my x coordinate is getting more and more closer to -1. And you'll see that in the graph. All right, so now that I got all the points plotted, I can just connect the dots, and then that'll be what the cosine function looks like. All right, now of course it's not perfect, but it is a pretty rough sketch of what it looks like. And you'll see that the reason it makes a wave is because the cosine function is just a measure of how far away you are horizontally from the origin as theta goes around the circle. So to start, your x value is already as far as it's gonna get, which is 1. And then as theta gets bigger, in the first quadrant, your x coordinate gets smaller. Your x coordinate is decreasing. So from 0 to pi over 2, that's why our graph is decreasing. And then from pi over 2 to pi, it gets even more smaller, closer and closer to -1, as you can see right here. And from pi to 3 pi over 2, my x coordinate gets closer and closer to 0, closer and closer to 0. And then from 3 pi over 2 to 2 pi, it goes back getting bigger, closer and closer to 1. And that's exactly what happens in the graph. So that's kind of the reason why it makes a wave, is because it's just something getting further away from a number and then closer to a number, and all over again. So if I went all the way to like 4 pi, 8 pi, it would just repeat. All right, now for the sine function, you know how it's equal to opposite over hypotenuse? Well, since the hypotenuse is 1, our opposite is just going to be the y coordinate of all of these points. So just like how I did the cosine function, I'm going to do the sine function, and then we can talk about what that looks like. All right, so that's pretty much what the two graphs look like. Hopefully this answers your question as to why both of these graphs kind of create a wave effect. And it's simply because you got to realize that theta is your input, and theta is just an angle that rotates in one full revolution. So as you rotate, either your horizontal distance, if you're talking about the cosine function, or your vertical distance, if you're talking about the sine function, it's going to increase or decrease depending on where your angle is at. So yeah, in summary, make sure you understand where all of these points come from, and make sure you understand the radian conversion from degrees. And then if you understand that each coordinate point is the cosine and the sine of that angle, then you basically know the fundamental beginnings of trigonometry. Hopefully that video helped. If it did, make sure you leave me a thumbs up. Hit that subscribe button if you're new. And with that being said, I'm out.